Hello, we're going to talk about absolute value and absolute value equations. So let's remind ourselves what absolute value is. If we put a number like 7 inside the absolute value signs, what we're going to get is just the number 7 again. Anytime you plug in a number that's positive or 0 into absolute value signs, you just get that number. So let's say 3.5, you're going to get 3.5. If you plug in a negative number into absolute value signs, something like -2, we're going to return the positive value. So any number you plug into absolute value signs, you're going to get the positive version of it. If the number is already positive, then you get that number back. If it's negative, you get the positive version. So let's say we have -pi, you're going to get pi. We're going to solve the following equations. First off, we're going to just think about the solution, and then we're going to graph them. So here I have the absolute value of x is equal to 5. What I want to find is all values of x that when I plug them into the absolute value signs, I get 5. So let's think about this. Definitely if I plug in 5, that will work, right? The absolute value of 5 is 5. Also, if I plug in -5, you plug that in, you'll get 5. How you can think about this is whatever you see, when you isolate the absolute value, so you have the absolute value of something is equal to some number, then you can say from this spot, I'm going to have two options. X is equal to the number I see, or x is equal to the negative of that number. And that's how you're going to find this. Now, the way I thought about it was I just thought of two numbers that worked. But what you're going to do, because we're going to see things that are more complicated, you have absolute values equal to a number. Then you're going to do whatever you see here, x is equal to that number, and then x is equal to the negative of that number. And you'll see as we do more problems, this will get more complicated. But I do want to bring up that another way to solve this, I guess it's the same way, but we're going to use graphing because the absolute value function, we know what that looks like. This was one of the functions we had to memorize when we were learning transformations of graphs. So let's graph this. If you recall, the absolute value function is V-shaped. It goes through the origin 0, 0. It goes through 1, 1, 2, 2, 3, 3, 4, 4, and so on. So I'm going to keep going. I'm going to go a little bit further. And it also goes through -1, 1, -2, 2, -3, 3, and so on. So it's a perfectly shaped V. And you can double check this because what do? Well, if you plug in x is equal to -1, the absolute value of -1 is 1, so that's why I have the point -1, 1. Okay, this graph is symmetric. It's symmetric with respect to the y-axis. So whatever I have over here is also over here. So this is the function, absolute value of x. And now what we're doing, if you look back at what we have, we are setting the absolute value function equal to this number 5. Now this number, you can think of this side of the equation as the line, and it's a horizontal line. Y is equal to 5. Let's graph that. So here is 5. So let me write y is equal to 5. And this black graph is f of x is equal to the absolute value of x. Now what you can think of here is I have a line and I have the absolute value. And when they're equal to each other is when we cross, when these two lines cross each other, intersect each other. And you can see that they intersect when x is equal to -5. We get y is equal to 5. And when x is equal to +5, we get 5. So that's another way that you can solve this, by graphing. You think of the left side as a function and the right side as a function of this equation, and where the two functions intersect will be the solutions to this. Let's try another one. Here I have the absolute value of x is equal to -1. Okay, what we're going to do is first think about, is this even possible? Can we take the absolute value of a number and get -1? And the answer is no. This has no solution. Because if I plug 1 in here, I'm going to get +1. And if I plug -1 in here, I'm going to get +1. There's no way I can get a negative, because remember, the absolute value always returns a positive number. So this is going to have no solution. So whenever you have absolute value is equal to a negative, then there's no solution. Let's graph this. Now, the left-hand side is f of x is equal to the absolute value of x. And the right-hand side is y is equal to -1. Or you could call this, we could use a different notation. We can use functional notation and say g of x is equal to -1. And what we're doing is we're trying to see when f of x is equal to g of x. So what are the x values for when the function, the absolute value of x, is equal to the function -1? And that would be where the two functions intersect. So again, we're going to graph this. This, we already know what it looks like. Looks like this. Okay, this is the absolute value function. And then this side, right here, this -1, this is a line. The slope is 0, it's a horizontal line, and it goes through -1. And so we ask ourselves, where do these two functions intersect? And you can see that they don't intersect at all. And since they don't intersect, there is no solution. So again, there's two ways to think about this. You can say, oh, absolute value can never be a negative, so there's no solution. Or you could graph the left and the right-hand side as different functions and see where they intersect. And if they don't intersect, there's no solution. Here's the next problem. The absolute value of x minus 4 is equal to 3. Okay, step 1. What we're going to do is when we isolate the absolute value, that means we don't have anything on the left-hand side other than just absolute value of something. When you have that, you're going to say whatever's in the absolute value, x minus 4, is equal to this number. And, or you could put or, doesn't matter, x minus 4 is equal to -3. So you're going to have two options. X minus 4 is 3, or x minus 4 is -3. And then you solve for x. So to solve for x in this equation here, I just add 4 to both sides and I get 7. I'm going to do the same thing over here. I'm going to add 4 to both sides. But when I add 4 here, this becomes 1. So I get two solutions. X is 7 or x is 1. Let's plug them in to double check. I always recommend this because it's easy to make an error like when you're doing math. So let's see. If I plug in 7, I get 7 minus 4, which is 3. And the absolute value of 3 is 3, so this one is correct. When I plug in 1, I get 1 minus 4, which is -3, and the absolute value of that is 3. So this is also correct. You should always get, you'll get two solutions unless this is equal to 0 or if it's a negative. If it's equal to 0, you will get one solution, and if it's equal to a negative, you'll get no solutions. So if you get 3 solutions, then you've done something wrong. Okay, so what I'm going to do now is I'm going to verify this by graphing. And here we're going to use some things we learned a while back, which is transformations of functions. We're going to think of this side as a function f of x, and let's think of this side as a function g of x. This one's really easy to graph. Let's go ahead and graph it. We're going through 3. So here I'm going to write g of x. Now what about this side? F of x is equal to the absolute value of x minus 4. How can I graph that? Well, we think about the parent function. The parent function is the absolute value of x. Let's call that f1. So let's draw the parent function. And I'm just going to sketch the parent function here. So it looks something like that. And then how do I go from the parent function to this? What do I have to do to this function f1 of x? So this is f1 of x. Well, to get this one to look like this one, what I need to do is plug inside f1 x minus 4. That will give me x minus 4. And recall what this means when you plug a negative 4, this x minus 4, inside the function. That means you're moving the graph left and right. And because it's a negative 4, you're going to move it to the right 4 units. So every point, now we can put some points here just to get an idea of what we're going through. All of these points are going to be moved to the right 4 units. I'm going to start with the bottom one. This one goes here. So this one is 1 unit over, so that goes 1 unit over. And then I'm going to erase this so I don't get confused. You can see that this one goes here, 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 and so on. Now let's erase this parent function completely. And draw the new function. That wasn't very good. Let me try again. Okay, and now this is the function f of x. And now to see the solutions, we just find where these two functions intersect. And if we look closely, they intersect here when x is negative 1, and also right here where x is equal to 7. And that's exactly what we got when we set this absolute value equal to 3 and also negative 3. All right, things are getting a little more complicated. When you have something like this, where I don't just have absolute value over here, the first step is to isolate the absolute value. And what I mean by isolate the absolute value is on the left-hand side, the only thing I want is the absolute value. So that means I'm going to move this 4 to the other side. So if I add 4 to both sides, I get absolute value of x plus 2 is equal to 5. And from here, I have a problem similar to the last problem we just looked at. So what we need to do is say x plus 2 is equal to 5, or x plus 2 is equal to negative 5. Don't do this. Don't put this is equal to negative 1 and 1. You will probably get the wrong answer. You always need to isolate the absolute value. Okay, from here, now we just move the 2 over and we get x is equal to 3, or x is equal to negative 7. I want to graph this, and you don't have to graph this to solve this problem, but we're going to be working with inequalities soon, so knowing how to graph this and seeing the solutions will be very helpful in the future. So what I'm going to do to check my answers is I'm going to call this left-hand side of the original equation f of x. And I'm going to call this right-hand side g of x. Let's go ahead and graph g of x. It goes through 1. It's just a line. And now let's try to graph this one. So I'm going to write what this function is. This will also test our abilities to shift graphs. Okay. Now we need to define a new function. We're going to call it f1. Let's put it maybe in blue. f1 of x. That's going to be the parent function. So the absolute value of x, which I'm going to draw here. So it looks something like this. And it's always a good idea to put a few points here. One here, one here, one here. You could do more if you want. Okay, so this is the absolute value of x. What do I have to do to this function to make it look like this one? Well, I need to make 2 steps. The first one is I can plug in x plus 2 into the absolute value. And because I'm plugging it into the absolute value, I'm plugging it into the function. That means we shift the function to the left 2 units because we have a plus here. So I'm going to move this graph. Everything gets moved over 2 units. So that's 1 unit. Here's 2 units. I'm going to erase this parent function because I'm going to get confused with all of that. Okay, that's enough for right now. So let's draw it like this. And so this is the function x plus 2. And now we're going to label this function. We're going to call it f2 of x, if you remember doing these transformations of graphs. So this is a new function, f2 of x. And the reason I'm doing that is because I need to make one more change. So what I'm going to do, I'm going to get this new function, f3 of x, which is taking f2 of x and subtracting 4 on the outside. When I do that, I'll get the function I want, because I'm just taking this one and subtracting 4. But because it's on the outside of this function, that means I move the function down 4 units. So everything gets moved down 1, 2, 3, 4 units. So this one goes here. And I'm going to put a bunch of dots because I want to see where it intersects this green line. And I know that to draw the absolute value signs, we just go up 1 over 1, up 1 over 1. So you can see here, we're going to cross. And then over here, up 1 over 1. So we're going to look like this. And where do we cross this green line? Well, you can see x is -7, and also x is 3, just like we found before. I think I have, let me show you the other 2 problems. Actually, it looks like 3 problems. Nope, 4, 5, 6, and 7 problems. Okay, I want to show you the problems. So I'm going to stop for a second and just show you what I have. And I want to see if you can solve some of these on your own. So what you're going to do, put some space, write the problems down, try to solve them, check and see if you get the same thing I get. And if there's something that you did get wrong or you don't know how to do, watch me do these problems. So this is number 5. This is number 6. Here's 7. Here's 8. Problem 9. Problem 10. And problem 11. I tried to make this as complicated as I could. And if you can get this one, then you can do any of these problems. Okay. All right, so problem 5. I am going to, again, we can do it 2 ways. This can be our function f of x. This can be our function g of x. I'm going to graph it first because you can see this is the absolute value moved down 7. So this function looks like this. I don't even have to go that far up, but I'm going to. Should be enough. Okay, here is f of x. And then let's draw g of x, which is -5. It goes through right here. Our 2 solutions, as you can see, are -2 and +2. Let's also do this by isolating the absolute value. So we're going to do this a second way. Move the 7 over, we get absolute value of x is equal to, add 7, we get 2. And from here, because this is isolated, we get x is equal to 2 or x is equal to -2. And those are the solutions we found just a minute ago. Also, we can plug them in into this original equation here. So 2, absolute value is 2. If we subtract 7, we do get -5. If you plug in -2, you get absolute value, which is 2, minus 7, you get -5. Here's problem 6. It says the absolute value of -x is 4. I think what I'll do, well, let's solve it. Because we have the absolute value isolated, we can say -x is equal to 4 or -x is equal to -4. Don't let this negative confuse you on the inside. It's on the inside, so we're just going to do the same thing. Whatever we see inside the absolute value, we set it equal to this and also to the negative of it. So solve for x, you get x is -4 or x is 4. And then just plug it in to double check. Plug this -4 and you get +4. Absolute value is 4. Plug 4 in here, you get -4. Absolute value is 4. So they both work. I want to graph this. This is f of x. This one's g of x. I'm going to graph g of x first. And how would I graph this one? So this is saying f of x is the absolute value of -x. So if we let f1 be the parent function, which is the absolute value of x, that looks like this. And then we're plugging a negative inside the function to go from absolute value of x to -x. You have to define a new function, which is equal to this f1 with a negative plugged in. And if you remember, if we put a negative inside the function, that corresponds to a reflection about the y-axis. So we just take this function here, you see that the absolute value, and flip it with respect to the y-axis. Now if you do that, this piece goes over here, and this piece goes over here. Because this is an even function, when you reflect it about the y-axis, you get the same function. So this actually happens to be f2 of x, which is the absolute value of -x, what we wanted. Okay, and you can see that we go through -4 and 4, just like we had expected. Let's move to the next problem. We have -x minus 3. Let's solve it the easy way, which is just take whatever's inside that absolute value, set it equal to 2, and also set it equal to -2. Move the 3 over, you get negative x is 5, negative x is 1. So we get x is equal to -5 and x is equal to -1. Those will be our two solutions. I'm going to graph this just so we can see it visually. You don't have to do this. This is this function here, g of x is 2. This one, let's think about how we can graph this. So if f of x is equal to the absolute value of negative x minus 3, we're going to define the parent function. I'm just going to draw a few points here for the parent function to get an idea. How do I go from here to here? Well, the first thing I could do is I could subtract 3. So I'd define a new function where I take this function, the parent function, and put in x minus 3. That will give me the absolute value of x minus 3. So that means I shift to the right 3 units. Okay, let's erase this one. Like that. So this is f2 of x. Is not what we want because we also need a negative here. In order to get that negative, we define a new function, f3 of x, where we take f2 of x and we plug in a negative x. And if we do that, we get negative x minus 3. And remember, if we plug in a negative x, we flip it with respect to the y-axis. So that's what we're going to do with this function. I'm going to put it in blue. So this point, let me erase this one here because I don't want that one to confuse us. If we flip with respect to this axis here, this point goes here. This one stays here. This one goes here. This is at 3, so then it goes to -3. And we know what this graph looks like, so we can finish drawing it. Erase this one. And now let's connect these dots. Okay, now we look and see where these cross. Now, I didn't do a very good job of connecting these dots, did I? Right here. Where do we cross? We cross at -5 and at -1, just like we have up here. Oops, let me scroll back down. Okay, here we're on problem 8. We have 3 plus 2, absolute value of x plus 1 is 5. Again, the first step you want to do is isolate the absolute value. So that means let's move this 3 to the other side. If we move the 3, we get 2 absolute value of x plus 1 is equal to 2, subtracting 3. Then get rid of this 2. When you get rid of this 2, you get x plus 1 is equal to 1 because I'm just dividing both sides by 2. So now that I have isolated the absolute value, I can make this x plus 1 is 1 or x plus 1 is -1. Move the 1 to the other side, so subtract 1, you get x is 0 or x is equal to -2. Those are our two solutions. Okay, and maybe we can graph this as well. Just for fun, go through 5. That's this side. Now this side is pretty complicated. It's going to be a little tough to graph. So we do what we normally do, which is draw the parent function. And let's break this down. How can we shift this parent function? So what do? Notice that we have this +1 on the inside of the absolute value. That means we shift to the left 1. We have a 2 on the inside, like right here, on the outside of this absolute value, which means we stretch by 2. And then this 3 means we move up by 3. So let me break this into pieces. The first thing I would do is, if I define a function, absolute value, which is right here, I would define a new function where I plug in x plus 1 into the absolute value. And that corresponds to moving this graph over 1. Then after that, I define a new function. Let me erase this because I want some room. I define a new function. How can I get this one to look like this? Well, I would multiply by 2 next. So 2 times f2 of x, which would give me 2 absolute value of x plus 1. So let's think about what we did. So we're going to shift to the left 1, and then we're going to stretch by 2. And the final thing is to move up 3 units. So we define one more function, which is taking f3 and adding 4. And that will give us adding 3. And that will give us the function we want. Okay? So let's see. We move to the left 1. Okay, erase this original function. We stretch by 2. That means any x value you put in, you multiply the y value by 2. So here I go, if I plugged in, and you can double check this, if you plug in 0 for x, you'll get 2 for y. If you plug in 1, you'll get 4 for y. So then this one, you had a 2, multiply it by 2, you get 4. And then here, for 3, if you multiply it by 2, you get 6. And then you do the same thing over here. Remember that it's symmetric, so you just take the mirror image. Make sure I did that right. 2, yeah. So now your graph should look something like that. Again, you don't have to do this, but this is helpful, like to make sure you know how to do transformations of graphs. And then we move the graph up 3. 1, 2, 3, we get a point here. This one goes up 1, 2, 3. And then this one goes up 1, 2, 3, and this keeps going up like that. I don't really have to find any more points because I need to find what's lying on this line here. And you can see that x is equal to -2 and x is equal to 0, just like we suspected. Okay, let's look at the next problem. Here I have 1/3 x minus 3 is 2. So since the absolute value is isolated, we just set this equal to 2, and we set it equal to -2. Move the 3 over. Plus 3, you get 5, which tells me x is equal to 15. And then 1/3 x plus 3, that gives me 1. Multiply by 3, I get x is equal to 3. I'm not going to draw this one because 15 is not even on my, my plane here, but you can see that one of them is going to go through. So if you put 2 here, what you're going to get is that you're going to go through 3, and you're going to go through 15, which is way out here somewhere. So like this will be 15. And then you could finish drawing this if you wanted to, because you can see that this is pointing upward. We don't have a negative with the X or on the outside. And we don't move up. We just move to the right and we stretch our graph. So halfway between these two, because this is symmetric. So 15 plus 3 divided by 2 is 9. So at 9, you're going to have a graph. If you wanted to graph this correctly, your graph would look something like this. And you would see that you're going through 3 and also 15. Okay, next problem. We have 5 on the outside of absolute value with a negative x plus 3 is equal to 10. Again, first thing to do is to isolate the absolute value. So divide everything by 5. And then because this is isolated, you say this is equal to 2 or negative 2. Put the 3 on the other side. And you get x is 5 and x is 1. I can graph this. 10 is actually really up here, so maybe we can extend this. This would be 7, 8, 9, 10. So we're going to just draw like that. So this is g of x. Let's think about what we have to do to get this. We would have to take the absolute value function. Just going to sketch it here. We would have to move it to the left 3. So it looks something like this. If we move it to the left 3, because I have that plus 3 in there, we would flip it with respect to the y-axis. So then this point would go here, and here, and here. So something like that. And then the last thing would be to multiply everything by a 5. So this point would stay there because the y value is 0. 4, we got a 1, so that would go to 5 instead. This one would also go to a 5. If you went through this point, which is 5, it would go to 10, which is up here. And this point that is lying right here, which was 1, 2, if you multiply that by 5, you go to 10. So your new graph would look something like this. And you can see that when x is 1, which is right here, and when x is 5, which goes here, I moved it a little bit too far over. Right there. That we go through this graph of 10. Okay, here's the last one. Let's see what kind of answers we get. And then I don't really think we need, this is a little too complicated to graph, so let's not even worry about graphing it. Let's just do the algebra. So what we need to do is we need to isolate the absolute value. So the only thing we want on the left-hand side is the absolute value of something. Okay, so what I'm going to do is notice I have a -3 here. I'm going to add 3 to both sides. So I get -2, 5 plus 2x is equal to -6. Okay, then notice that I do, and in the very beginning, I was equal to a negative number. Is that a problem? And the answer is not necessarily. You only have a problem when you have the absolute value of something is equal to a negative. If you have some other stuff like we do here, we could possibly get rid of this negative. So we're going to continue with this. If we divide everything by -2, you see that we actually get rid of the negative. This just becomes 3. And now that we have isolated the absolute value, we can set this to 5 plus 2x is equal to 3, or 5 plus 2x is equal to -3. Subtract 5 from both sides. You get x is equal to -4, and x is equal to -1. Again, I recommend that you double check by plugging both of your answers into the original equation. Let's do that. So I'm going to move this up. Okay, I guess it's not moving up, so I'll just write it up here. This is the answer we found. X is equal to -1, and x is equal to -4. Let's see if that works. Just going to plug them in here. So I get -3 minus 2 times 5 plus 2. Let's start with this one, -1. Does that equal -9? So you get -3 minus 2. Inside you get 5 plus 2, which is 7. Does that equal -9? Oh, sorry, I made a mistake. This is a -2, so this should be 3. So then I get -3. Absolute value of 3 is 3. And so this is -3 minus 6. Does that equal -9? And yes, it does, because you can see that if you add these, you get -9. So this is true. Let's try the other one. For x is equal to -4, we have -3 minus 2, 5 plus 2 times -4. Does that equal -9? So we get -3 minus 2. Simplify the inside. This is -8. 5 plus -8 is -3. The absolute value of -3 is 3. So we get -3 minus 2 times 3. Does that equal -9? So here we have -3 minus 6. That does equal -9. So this is the other solution.